everybody. Welcome to topic 5, lesson 2. So we are going to start with kind of some definitions and notes, and then we'll get on to that problem that you just saw for a moment. So we're talking about linear equations in the form y equals mx. Now remember that this means m times x, anytime you see two variables together like that. And our essential question is, how can what I know about proportions and the constant of proportionality, which we can also call the slope, help me to write linear equations? So remember from lesson 1, if the relationship is proportional, then it can be written in this equation form, y equals m times x. Now, y equals m times x means that x times m equals y. Okay. And in this case, m is the constant of proportionality. And yes, write the whole word out, which can also be called slope. Slope has many names that we will learn in this chapter. So m stands for the constant of proportionality, and the constant of proportionality is always a ratio. Okay, so the ratio is the change in y, which, remember, the y-axis is vertical, so that's the rise of a line, over the change in x, which is the side-to-side movement, the run. So change in y over change in x would be the mathematical way to say it. But we often just say rise over run. It's the quick and easy way that's still mathematically appropriate. All right. So we're going to start with writing an equation. And I'm not going to go into the graph yet because it'll keep us on this page for now. So to write an equation, we have to identify the input. Okay, what's the thing that is happening? It is the independent variable. Then we identify the output. And then we can identify the proportional relationship, slope, rate, etc., and put it into the right form. So in this particular example, we're going to have a lunch special. Okay. The restaurant overbought. The restaurant has some things that are going to, spoil if they don't get used. So they would like to give us all a deal. So whatever my sandwich usually costs, okay, is X. I know that I don't have to pay 1/3 of that. So 1/3 of this is going to go away. Okay. But I do need to pay 2/3 of it. So if you notice, I figured out, oh, well, whatever the amount is, if I'm taking 1/3 away, I have to pay 2/3 of it. Okay. And that's going to equal the new price. Okay. So let's try that. If the new price is Y and the constant of proportionality, the amount that is being changed, is 2/3, and I multiply that by X, am I going to get what I want? Well, what if it was a $6 sandwich? That seems reasonable. which would mean x equals 6. Well, then I could evaluate this expression or this equation, y equals 2/3 times 6. Now, depending on how much you remember of multiplying fractions, y equals 2/3 times 6/1. Y equals 4. So my sandwich is now $4, which is a reasonable answer of something being 1/3 off on sale. I saved a couple dollars on my sandwich. Okay. That is how we would put this into an equation, and we will do lots of practice with this. Now, the other thing that we can do, and I have a graph pre-written here, but I want to show it to you somewhere else. And it's right here. The graph shows the distance d of a car traveling in time t at a constant speed r. It's just saying that for every 1 hour that the car goes, it's going a certain distance. The very first question it's asking us based on this graph is, what's the constant speed? Then it's asking us how far in 2 hours. Then it's asking us how long will it take to go 120 miles? We all want to know how long till we get there. And last, write an equation. All right. So I took this same graph and I just took some printable graph paper that I have on my Schoology page and I rewrote it so that we could write next to it. So here we have the exact same graph. Okay. Time, there's your hours. Distance, 30, 60, 90, 120, 150. I could keep going. So the first question, A, asked, what is the constant speed? So this is you reading a graph. Well, in 1 hour, I go 30 miles. In 2 hours, I go 60 miles. In 3 hours, I go 90 miles. Oh, so my constant speed is for every hour, I'm going 30 miles. 30 miles per hour. Question B asked, how far in 2 hours? So in 2 hours, 1, 2, again, reading a graph, that's 60 miles. Part C asked, how long is it going to take us to go 120 miles? So we're driving from Lincoln to San Francisco. How long is it going to take us to get there at this speed? And goodness, I hope you get to drive faster than this. So 120 is right here. It meets up with the line right there. So if I follow that down, it's right here. 4 hours for 120 miles. I don't wish that on anyone. Okay. So really what we're practicing here is reading the graph. What does it say? What does it mean? Now, how do I take this information, specifically constant speed, and turn it into an equation? Well, I know my form is y equals mx. Here's x, 1, 2, 3, 4. Here's my y's, 30, 60, 90. What verb, what action is causing me to get from X to Y? It's this. Okay. So if you're a person that likes color coding, notice the match here. Therefore, I can write an equation that says y equals 30x. For every hour I spend in the car, I'm going to go 30 more miles at this constant rate of speed. Okay. So hopefully that helps. We'll give you plenty of practice. Have a great day.